Good afternoon, everyone. Welcome to my presentation. Today, my topic is machine vision-based prediction of serum vitamin A level in Japanese black cattle by pupillary light reflex analysis. And first, this is the outline of my today's presentation. First, the background. In background, I will introduce that vitamin A level will affect beef quality, and the objective, we want to find an easy way to monitor vitamin A level of cattle. And the device, we are using 2 CCD camera, and method, we want to investigate the effect of different vitamin A level on pupillary light reflex in Japanese black cattle. First, background. And please look at this graph. This graph shows the main cattle in Japan. The beef was divided into 5 grades, and all the right side is beef marbling standard. It has 12 standard, and all these standard contribute to the beef grading. And we are doing experiment in Tajima-gyu, which is the same kind with Kobe beef. And the Kobe beef is famous for its good taste and high price. And this figure shows 12 beef marbling standard, and the down right is the highest standard, 12. And this is determined by the intramuscle fat. And to keep the cattle and low vitamin A level during stage of fattening can produce beef with higher marbling score. And this is proved by many research. And in 1998, Okasan find the mean marbling score of low vitamin A group was significantly higher than that of group supplemented with higher vitamin A. And in 1999, also another research proved the same thing. And also in 2007. And so to get high quality beef, it is important to control the vitamin A of cattle in lower level. However, if that is too low, it will introduce some disease to the cattle, like night blindness, diarrhea, and xerostomia, and convulsive seizures. The traditional way of monitoring vitamin A level is by blood assay, which has disadvantages, which is time-consuming, expensive, and stressful to cattle. So, to publish the research in Japan shows some potential to predict vitamin A level by analysis of pupillary light reflex. The left side is conducted by Matsuda-san, and which showed the lower vitamin A level cattle need a long time to react to the light. And the right side also showed the same result. Lower vitamin A levels cattle need a long time to contract. So there is a hypothesis that vitamin A deficiency would introduce defect in optic nerve of cattle. When vitamin A becomes lower, the cattle's eye become less sensitive to light. So our objective is to predict the vitamin A level in Japanese black cattle by pupillate reflex analysis. This graph, the right graph shows the device we are using, and the left side movie showed the pupil shrink in 1 second. This is the device now we are using. The right side is a 2CCD camera, and it can get two kind of images, both color image and near infrared images at the same time. And in the middle of the device, there are two kind of light source. One is ring-shaped near infrared light, and the other is white LED light. The left side is a tube to reduce the environment noise, and this side is cattle's eye. This is the real image of our device. Material we are using is 42 Japanese black cattle, which belong to Tajima-gyu. And the cattle's age at the start of this experiment is 9 to 10 months old. And we conducted this experiment during last December, and by now the place is at Hyogo Prefecture, Hokubu Agricultural Institute in Wadayama. And this graph shows the period we conducted this experiment of the cattle's age from 9 months to 22 months old. The method is, first we fix the cattle's position, and then use a black cloth cover the cattle's eyes, and then we wait for 2 minutes to wait the cattle's pupil dilated, and then put the camera in front of the cattle's eye, and then adjust the camera's position by checking the near infrared image, and last turn on the white LED light and take PLR images. This slide shows image processing. We find that in the hue value that the pupil area is easily to separate from the image. So we first convert the color image into HSI space, hue, saturation, and intensity, and then binary in hue value. And then we do noise reduction and fill the LED ring. And last, count the number of the pupil area. This is the result. We try to analyze the relationship between the serum vitamin A level and pupillate reflex factors. We included 5 factors: pupil area, normalized pupil area, start of shrinking time, slope of pupil contraction regression line, and ratio of pupil maximum length and breadth. The slope of pupil contraction refraction line corresponding to the contraction speed, and the ratio of pupil maximum length and breadth corresponding to the initial shape of the pupil. The left side is the pupil area of one cattle in different months, which is affected by, however, the initial area size is affected by the relative position of the camera and the cattle's eye, and has variation in different experiments. So, to evaluate the pupillate reflex, we normalize the pupil area by dividing the initial pupil area. This graph shows normalized pupil area. And we define the start of shrinking time is the time when the normalized pupil area decreased to 0.98. This is the result of start of shrinking time. And we conducted this experiment from 2010. So last year, previous researcher in our laboratory found a slightly positive correlation between start of shrinking time and vitamin E level. The left graph shows that the x-axis is vitamin E level and the y-axis is start shrinking time. However, this year we try to analysis in the same way, but there is not obvious relation. We just got a scattered point in this graph. And then this slide shows the slope of pupil contraction regression line of one cattle in different months. We use this slope to represent the speed of pupil contraction. So the right side is the relation between the slope of pupil contraction regression line and the serum vitamin E level. And it showed a little slightly negative correlation. However, I divided the sample of cattle by their age. So one group of cattle showed a much better result. It showed that the negative correlation between contraction speed and vitamin A. However, by now, our research, I didn't consider the initial shape of the pupil area. But I think that the ratio of maximum length and breadth of pupil before shrinking maybe have some effect on the iris, sphincter muscle, contraction ability, and should be considered. This graph, the yellow color is the pupil area, and the green line is the maximum length, and the black line is the breadth. So discussion, a positive correlation between start of shrinking time and the vitamin E level was not confirmed by this year. And a negative correlation between slope of contraction regression line was shown. The result is different from other researchers' result and my hypothesis. I think this is a new result I have to consider. Future work. Now I just consider each factor directly with vitamin E level, but I think these three factors has correlation with each other. So in the future, I want to use a multiple linear regression line to combine these three factors. And also during during experiment, I didn't consider about temperature and birthplace and the gender of the cattle, which maybe also have influence on the experiment. Thank you.
On background, you have many Japanese. I think audience cannot understand Japanese. How modify some, or you need some to show us that this stage. And many cattle names. Maybe this is not easy to understand. Even if it's Roman letter, maybe difficult. Modify. Another next one. Oh, okay, just very short.
Oh.
Very short. Yes. The important data is just a grade 1 or Marvin score, which
Marvin standard.
Marvin standard is 1, 4, 7,
1, 2, 3.
10.
Yes.
Very small and it's not easy to see. All same. Just something, maybe you have another way to show.
Is number 12 best or number 1 is best?
Number 12 is best.
So what you should do is switch your scale, because from my understanding, the very last one is the best one, right? The lower right hand side, the very bottom one. So if I read it, that's rank number 1, A1. So what you do is change the numbering. The first one is 1, and then we Oh, okay. And what is 1 to 12 mean? What's number 1, number 12 on your no, yeah, large column.
Yeah, you are doing this is grade 1 or Marvin standard 1. Then this is Marvin standard 0. This is Marvin score 1 to 12. Down, bottom to up. This is up to bottom. Something. Then this is grade 1, 2, 3, 4, 5.
Yes.
Something like that.
One is good, right?
Yeah, confused. We confused.
Yes, yes.
And Mr. Han, when is the meeting? Next week? Okay. I'm trying to do it very, very careful reading your slide. It appeared to me your presentation have 2 stages. The first stage is before, from slide 1 to slide 12. You're doing just fine. But after slide 12, you lost your energy. You're beginning reading your slide. You're very uncertain. You're very slow. So what you need to do is you really have to practice so your presentation could be very consistent from slide 1 to your last slide. Because your first 9 minutes, you're doing okay. I look at after 9 minutes, you can completely drop off. So you have to be really, really trying to practice and consistent. because at the end you have no confidence on your presentation at the end. You're just reading your slide at the end. So you really, really have to practice. Now, just a couple of things, since this is an important meeting for you. Can you go to slide number 9? So instead of say material, you should say test animal. Okay, that's not material. So just little things to improve it. So test animal. Slide number 10. What you need to do is that trying to do your transition so the error won't be there. Okay. The arrows.
Oh.
Okay. Now, one thing I think for you to consider, your title is to make prediction. I think I would use the word estimation or something is better, because one thing is that if you look at this slide number 14, at the end you can see the reference. You have estimation of certain vitamin A level. I think estimation is a much better technical term. It's a prediction. Prediction is no measurement. Estimation, you make one measurement to predict the value for another one. It's an estimation. Prediction is no test. Okay. Another thing is that your conclusion, I would say, very weak. That's you should make your conclusion very strong. Your conclusion is that my result not very conclusive, and I don't really the conclusion really not helping you to strengthen your research. So you should have to reword your conclusion, make it much stronger technically. Okay. So, for example, the result is different from other researchers that might have say exactly what they mean. Yes, I can see the effect. No, I don't see the effect. Okay, make the conclusion strong. You need to practice. Okay. You're doing fine. The first nice stuff.
Thank you, Sensei.
Any other suggestions?
Yeah, just a few technical things. You could make your voice louder voice.
Oh.
Look at the audience. Didn't look at the audience at all. And for some reason you were not using the pointer. There's a pointer there. Somewhere.
Oh.
Just use the pointer.
Oh.
Okay?
Oh, there.
Pointer there.
And I think that you should get to the results faster. Maybe even reduce the amount of background on marbling the score and so on. You just need one slide about marbling the score. But get to the results and spend more time on the results. Because you're comparing your results with other people's results, audience has to digest the two studies. Actually, I think your project was a difficult one because you're dealing with animals. You're dealing with biological changes to animals. And you mentioned two hypotheses. And I think it's good that you did. One was that maybe there's damage to the optic nerve. But maybe, we don't know. Maybe the vitamin A level was not low enough for long enough to cause any damage. That's one possible biological. The other is their iris muscle contraction. And again, is the vitamin A level low enough, long enough to cause changes to those muscles? These are tricky biological questions we're dealing with. So you shouldn't be afraid to admit that. You're dealing with a difficult project.
So you can add those points as your conclusion instead of, like Martin said, in the case that you're trying to correlate a biological response with different animals. So the results are difficult to interpret. So that's part of your conclusions. Okay, so make the conclusion much stronger. Mm-hmm. It's very easy for us to spot when you lost confidence because your voice is getting very soft. When you lost confidence at the later slide, so make sure you show people you're highly confident. Okay, look at the people. Don't be afraid. Practice.
And also, when you were talking to me about this a couple of days ago, you said that you're going to take the data and look at a subsample of the data because you have cattle of various ages, so you're going to try to reduce the sample and look at the subsample and see if you can get a nicer correlation. I think you can include that here. I think it might get people thinking about it more and keep the interest up in the talk.
Also, you need to double check that someone check your grammar. There's many grammar mistakes. Okay, many grammar mistakes. At least several per slide, so you need to look at it. Okay.
Anything else?
Sorry, I have a question to Hassan about recency and also non-consistency related to the presentation. And maybe we have some suggestion that we can rearrange or make the conclusion much stronger. Maybe in case that we already submitted the manuscript, and then we say that maybe we think that the conclusion or maybe some part of our manuscript is not so good or maybe not so strong, and then we want to change during the presentation. Is it okay?
I cannot speak for Malcolm Sensei, but as far as I'm concerned, your presentation, the last minute's presentation, you can change it any way you want.
I agree.
Having the manuscript that prepared 2 months ago is not necessary to affect how you present the seminar. What people in the audience is, they do not have your manuscript. They only have your presentations. So what you need to do is that it's not too often you have a chance to make a presentation in front of people. You want to do the very best job. You want to do it in such a way you show people high confidence, and you want to present people the way that you can present. Don't make a presentation you cannot be prepared because you lost confidence. Even though the material might not be perfect, do it in a way that you have confidence. So don't worry about what the abstract is, what's the manuscript. Make the presentation and say, okay, I can make a presentation the last minute if necessary, so that I have absolute confidence. The same thing with Dickling and same thing with Mr. Han. High energy, the first 5 or 6 slides, and then drop off. What that means is that you're losing confidence. Very, very easy to see because I can hear your voice. So one thing you need to do is a 15-minute presentation. Make sure you do it very slow. Make sure it's very strong, especially on the conclusion, so people remember your conclusions. Don't be wishy-washy. Okay. My result so far is not conclusive. That's strong. It's okay. My results are conclusive. I will do better. But very strong. Tell people what did I find, what did I want to do next. Okay. It's okay to change.
And all you improve based on our discussion. Hassan, we believe that you can improve more.
You can do more. Yeah, you can do quite well in the first 2 slides.
Thank you, Sensei.
Okay, thank you very much.